All right. We are on page 28. I already checked to see if you did it all. So let's go through this. Hopefully you guys spent the time really trying to answer these. It was only 4 questions you had to do. So I'm really hoping you spent the 6 minutes needed to complete 4 questions. It was okay, good. All right, so as the pressure gradient increases, the wind velocity. Now we took these exact notes on the page before. They were on page 27 at the top, so that would have been 1, or we walk through this. Guys, who remembers what the word gradient means? It is the change. It's really one way of thinking about it is the slope. So I think I showed you the way my student taught me to think about this yesterday with the hill. So remember, if it's a low gradient, how's the wind speed? Slow. So like if I was to sled down this sled is a little slower than if I made it a steep hill. Now how fast can you go down it? Faster. So the wind will blow faster, the higher the pressure, the gradient. So as the pressure gradient increases, what happens to the wind's velocity? Increases. So wind speed increases. The steeper the pressure gradient, the faster the wind. And that was word for word on the page before. Question 19, the following map represents a portion of the air pressure field at Earth's surface. At which position is the wind speed the lowest? So here is it's one of those connected dots for slightly older kids. What did we say? We just said the greater the gradient, the faster the wind. So we want a low wind speed, which is C. Why is it C? How do you know it's not a C? Lines are far apart. Now, guys, you need to know this for the quiz tomorrow. There is one of these maps on there. By the way, do you guys remember how to do connected dots for slightly older kids? Yeah. Hopefully you do, because there's one of those on the quiz tomorrow. Okay, yeah, it's an easy one. There's only 2 lines you have to draw, and I already drew a whole bunch of other ones, but then you have to connect the areas of equal pressure. So basically what I'll do is I'll give you a map that looks like this with a whole bunch of numbers on it, but maybe I left these ones blank. And now you have to draw them. Okay, do you want Mr. D to take you to the nurse? Okay, then you can wait till Trent comes back. So you connect the dots of all the equal all the equal pressures. There will be a very mini one of those on the quiz tomorrow. Now going up, we skipped 20, we go to 21. This looks like the land breeze and the sea breeze that we drew yesterday. So first of all, we want to read the question word for word. Which cross section best shows a normal movement of air over Oswego, New York on a very hot summer afternoon? So since it's an afternoon, what do we know about the water and the land? Who's hotter in the afternoon, the water or the land? Well, which is it? Land. Remember that land heats up faster than water. So during the day, the land is hotter. So I'm just going to draw this up here. So we have the lake and the land, lake and land. So we know the land is hotter. So if the land is hotter, what's the air doing there? Remember, warm air rises. So if the air is rising, what kind of pressure? Low. So what kind of pressure over the lake, which is colder? Air does what over the lake if it's cold? Which way does cold air go? Sinks. And if air is sinking, do I need to make you push on your desk? No. What kind of pressure do you have when you have cold air? Cold air sinks, so we have high. So, and then which way does the wind blow? From what to what? Just like farts, always goes high to low. Which two can I cross off without thinking too hard? And okay, I definitely think I could cross off 3. What's wrong with 3? What is 3 showing you? Oh, nice. Yeah, it is a high pressure. Remember, winds blow out of a high pressure. And they always go, do the winds go clockwise or counterclockwise around a high pressure? High pressure. Look how high that clock is on the wall. You guys remember that? Remember my analogy with the clock being really high on the wall and the counter being low? Oh, you got to know that for the quiz tomorrow. So wind always blows out of a high. It blows clockwise out of a high into a low, counterclockwise. You need to know that for the quiz tomorrow. So if this is a low, okay, it is going counterclockwise, but that wasn't really what we were talking about yesterday, is it? Yesterday with the sea breeze, it always comes, this is showing air coming from over here. Does air go that way? That's not what we learned yesterday. Both of these are incorrect. Now, we need to see which one is showing the wind blowing from a high to the low. Now, when you look at these, third period was saying, well, here, if this was a high and this was a low and this was a high and this was a low, they both saw wind going from high to low somewhere. So they're correct some ways, but only one of these is right. Keep in mind that we have a low pressure over here. We have a low pressure. Which way is air moving? Low pressure. Which way is air moving? Up. Which one shows air moving up over a low? That's harder than what's going to be on the quiz tomorrow, but you need to understand the high and low pressure. So there was a lot going on there, but when you walk through it, you know the air rises over a low. So we need the air going up over a low pressure system. And finally, like I've said, you need to know those weather instruments. You need to know their names and what they do and pretty much what they look like too. Guys, there's 3 questions tomorrow on weather instruments. So let's talk about this one first. An anemometer measures wind velocity or wind speed. What's the name of another wind instrument we learned this chapter so far? How about anybody but Justin and Jake, because they're the only ones answering me today. Good. A wind vane, and what's that measure? Anybody, you want to do that one or you want somebody else to? Wind vane? Is that what you said? Doesn't do air pressure. Air direction, sorry. Yep, you did say that. Wind direction, air direction, that works. So a wind vane tells us which way the wind's going. Give me another weather instrument we learned this chapter so far. Any of them, not. Thank you. Gonna make the rest of you, I'm gonna call on people if you don't answer me. So now not Riley, not Jake, not Justin, Shelby. Yeah, a barometer, more commonly called a barometer, but I like barometer better because that's way cooler. And somebody else, not Shelby, because I know she's already looking at the page. Don't make me call on you. No, not you, thank you. I appreciate it though. Don't make me call on you. So if you don't know, find where we wrote the word barometer. Oh, so anybody besides those 4 people find a barometer yet? You've already answered today too. How about anybody else? Thanks, Jesse. Oh, wait, no, I want to know what a barometer measures though, but we can go with you for that one next. Pressure. Guys, air pressure, barometric pressure are all measured with a barometer. If you see the word barometric pressure, it just is a fancy way of saying air pressure. So far we have a wind vane, which does wind vane direction, an anemometer, which does speed, a barometer that does pressure, and Jesse, you added a, yeah, sling psychrometer. Those are our spinny things. So somebody else tell me what those spinny things measure. Thanks, I appreciate it. Guys, what did we do in lab? Trent, you were just there yesterday. What did we measure when we did the spinny thingies? Well, then I guess you got to find the spinny thingy. One was humidity. Now, Trent, find the other thing you use to measure the spinny things with. Go ahead, find the spinny thingies in your notes. I know, I'm so mean. So one thing we use is the humidity. What's the other thing that gets measured? It does measure temperature, but it does the wet and the dry bulb. So Trent, what's the other thing? Yeah, we'll get up and see it then. Dew point. Guys, the swingy thingies, the sling psychrometers, they give you the temperature inside, or the air temperature and the wet bulb, which can be used for two different things, dew point and relative humidity. Oh, there's one more instrument we learned. Thanks. You were not supposed to answer. It was right there. The clock on the wall, remember? Okay, yes, the thermometer. And you guys all know what thermometers are for? Temperature. Oh, that was not convincing. Thermometers are used to measure temperature. You got to know all of those for the quiz tomorrow. Quiz is 14 questions long. I just told you three of the questions. Told you got to know the whole like lake stuff. That's on there. That's 4 questions. There's at least 3, maybe even 4 questions that use these. Hey, Kelvin, what are the 2 variables, meaning what's this labeled and what's this labeled up here? I think you've been struggling with this in lab today. What's this set of numbers? Dry bulb, which, hey guys, I'm not sure I screamed this enough. What is the dry bulb really a measure of? Just the plain old regular air temperature. So I know that was something Kelvin asked me today, so that's why so regular dry bulb temperature is just the temperature of the room. And then Kelvin, what's that top set of numbers for? The difference. You gotta subtract. If you just try to use the wet bulb, you're gonna get it wrong. And everybody in this room has probably done that once. Don't do it anymore, Kelvin. Thanks. And anyone else, he just happened to ask me twice today. Okay, thanks for being a good sport. All right, so I think I gave you almost every test question there is. Oh, I talked about you got to know the high, go clockwise and in or out of a high. Out, farts blow out of a high pressure. All right, I really think I just gave you all the answers to the quiz tomorrow. Hopefully you're paying attention. All right, so in the meantime, I realized we stopped here at Coriolis effect on the top of page 28. Oh, and I remember I lost it there. I just saw it. Guys, the Coriolis effect, which is a weird word, is the apparent bending of wind and ocean currents by Earth's rotation. I'm going to demonstrate this, make it make more sense, but if you could write this on the top of page 28 to start. Winds don't blow in a straight line. They curve, and I'm going to explain why. So I'm going to use an analogy here that anybody who hunts or plays football will understand. The rest of you, I'm going to give you a good demonstration for if you don't understand hunting and football. But even if you don't hunt or play football, you're going to understand the concept. It's not something, it's not like understanding like what yards and downs and stuff like that is. Okay, you ready for this? So who is a hunter or a football player? I just need a Trent, you're a runner in the football, right? Or are you a thrower? Or are you a knocker downer? You're a knocker downer? Oh, then that's useless for me right now. Anybody here a runner or a thrower in football? Oh, right. That's not very helpful. Okay, so let's picture hunting. So most of the time when you're hunting, you're aiming at things that are moving, aren't you? Or when we got the thrower in football, very few times does the thrower throw to a standing still target, do they? Aren't they usually running around on the field? So when you're aiming at a moving target and you throw the football or you shoot the gun at a moving target, what do you got to do? Lead it, which I've learned means, what do you do when you lead it? You aim in front of it. So for those of you who aren't throwers in football or hunters, picture throwing a ball or shooting at a target that's moving. If it's moving this way and I aim over here where it was, what's going to happen? I'm going to miss it. It's going to drive by me. How about this? I like to talk about Santa Claus. Okay, Santa Claus has been out all night delivering presents. He gets back to his North Pole, he pulls in the garage and realizes one of the presents that he forgot to deliver, your iPhone, to you, fell under his seat. So he's already up at the North Pole. He does not feel like going out again. Trust me, after all days of errands, when you realize you forgot one errand, the last thing you want to do is go back out. Santa Claus feels the same way. So Santa Claus has a few drones for just this, or they're more like missiles. So Santa has this missile that can deliver a few random forgotten presents in case of emergency. So Santa Claus is up here, pretty far away from the people down here, isn't it? It's a big space. So Santa, he calculates the coordinates and he has to deliver the presents to there. So it's basically like a giant missile, like an airplane situation. It doesn't travel instantaneously. It's not magic. It's just normal sending things off in the air. So he sends it off. Well, what's the world doing while that present's up in the air? Turning. So if Santa, I always mess up because you never see. So if Santa wants to send his present straight there, but the world has turned. If he shoots it in a straight line, is it going to get there? No, somebody back here is going to get that present. Their lucky day. They didn't even ask for an iPhone and they're getting one. Maybe they wanted an Android. And that aren't so happy. So what does Santa have to do? So if he shot it that way, so if Santa shot his present, how would that look if he shot it in a straight line, but the world turned? So he was aiming here and it got here. It would have looked like his path was that. You see what I mean? He was aiming it at that dot, but the world turned while it was up there. It would have looked like he shot it from the North Pole, but it curved. So Santa would have had to shoot it out ahead of it. That's called leading, for those of you who didn't know the whole football or the hunting thing. Well, guys, not only does Santa do this, but this is how the winds blow too. So if the wind was to carry the present from the North Pole, it would look like it was trying to go in a straight line, but it curves at the end. That's the Coriolis effect. The winds don't go in a straight line. They curve because the earth is spinning. You guys are still looking at me like crazy. Let's see if hopefully these links still work. I should have checked them earlier. I either just got a virus or I'm going to show you the video I wanted to show you. Oh, no results. I guess I should have checked that first. Let's try the other one. Oh, got a commercial first. Wait, where's my skip? Oh, perfect. This is the one I wanted to show you guys. I don't know if you guys, I hear there's still one of these merry-go-rounds at the arcade park. Am I still informed correctly?
Ours aren't that cool.
They aren't this cool. Oh, it's so blurry, but you're, oh boy. They've been basically outlawed everywhere else, so I'm not sure how you guys get to still have them. Is there really? Okay, so basically what we have, if you guys don't know what this is, it's called a merry-go-round. It's a small circle that spins in circles. They're outlawed because almost everybody breaks something on them at one point. And I'm not sure how they haven't at arcade yet and haven't been sued, but whatever. So if this was not spinning and this guy tried to get the ball over here, you just roll it across, right?
No.
If it's not spinning. Now when it spins and we want to get it to red shirt.
Yellow.
Oh, I went the wrong way, but see how it doesn't go in a straight, it doesn't look like it's going in a straight line. Looks like it's curving now. Oof. I'm getting dizzy just watching this. Okay. So again, they just curve. Do you have to fully understand the concept? You don't. You do just need to understand they curve because the earth is rotating. The other kicker is in the northern hemisphere, they always curve to the right. Here's how I remember this. I live in the northern hemisphere, so of course I'm right. A little cheesy, but it works. The northern hemisphere always bends to the right because I'm right. So here's what we got to do. Not there. On page 28, we need to draw these wind belts in. And you do not have to memorize this. I would like you to grab your reference table and open it up to page 14. But do not just start copying them. I want to make sure you understand some basic concepts. So we've already done the top of page 14. Now we're going to focus on the middle. Sorry, guys, it's page 14 in your reference table, page 28 in your packet. Right, just a whole bunch of flipping. So they already have all these arrows filled in. You do not have to memorize the way the arrows are blowing. But I just said they're bending to the right in the northern hemisphere. Take a look at the arrows going from the North Pole to 60. And in case you forgot your left from your right, remember that when your hands make the L, that's the left-hand side. So we're looking up here from the North Pole to 60. Are those bending to the right? They look like they're going to the left, don't they? Here's what I want you to do. Pick up your reference table and put it under your nose so that you're looking down at that. Now, if you are looking down at that globe, so basically you're putting yourself on that arrow. Now is it bending towards your right hand? Did the arrow switch direction when you flipped the paper? No, they didn't. The arrows did not magically change on the paper. But what did change is your perspective, the way you were looking at it. So how I describe it is you actually have to physically imagine yourself on that arrow, walking on that arrow. So if you look at that map upside down, so that if you were standing on this arrow, walking that path, now you're bending to the right. Now looking at the arrows going from 30 to 60. If you have your paper back the normal way, again, you can see yourself, okay, here I am at this arrow, and I walk that way. Now I'm bending to the right. For the 30 to the 0, again, you have to flip your paper over to see 30 to 0. Now I'm bending to the right when I walk. So they do all bend to the right, but you have to put yourself on the right perspective to look at it. A couple other things. Can we tell where the high and low pressures are on this world map? Take a look. By the way, the answer is yes. I wouldn't ask it. So you can somehow figure out where high pressure is and where low pressure is. In fact, let's look at the equator. Let's start somewhere. So the equator, what is the latitude of the equator, people? Quick review. 0. Not 0 or 180, just 0. Here's the equator. Somehow you can tell me if this is a high or low pressure. There's actually 2 different ways. What do you know about the way the arrows point? Try that again. Low pressure goes up, air rises.
Oh, yeah.
Oh, yeah. Also remember, farts always blow from high pressure to low pressure. So if these are winds, by the way, these arrows are winds. Maybe I didn't say that. So right here at the equator, are the winds coming towards the equator or away from the equator? So are they your butt or are they the regular air? Guys, winds blow from which way to which way? High to low pressure. So are they blowing towards or away here? Towards. So if they're blowing towards it, is it a high or a low pressure? Low, because remember they blow out of a high. Here's another way, still talking about farts. Guys, farts leave your butt. So the butts of the arrow are high pressure. The heads of the arrows are where the farts go to your nose on your head. So farts go from the butts to the head. So let's look at the 30. Is the 30 a high or a low? Is it a butt or a head? The butt. Do you guys know what I mean by the butt of an arrow? Okay. So the heads is where the point is. The butt is where like the head isn't. Okay. So this is the butt. So is it high or low? Ooh, high. And you could do that for all of them. One more way. The equator is labeled wet. Did my 8th grade science teacher teach me something that I taught you that would remind me that a low pressure system is wet? What did my 8th grade science teacher teach me to teach you? High, dry, cool and clear. So if it's high and dry, it's low and wet. 2 different ways of doing the same thing. So these arrows talk about how the winds typically blow in an area of the world. Where are we? Where approximately are we? You had to point to New York State. We think. Where would you be pointing? Wait, what? Huh? Where did you just pull the number 42 out, Jake?
I don't know. I remember doing
something. Remember doing something with 42. You are right. What the heck? So Jake's giving you a hint. What the heck does 42 have to do with anything? It's what? It's the latitude of New York State. Now, do you have to memorize this like clearly Jake must have? You do not. Remember, we have a reference table. New York State's latitudes go in the 40s. We're at 40 something down here, up to 45. So the 40s are in here somewhere. So it's saying our winds typically come, we have what's called southwest winds. They come from the southwest. Now picture the weather person up there doing a report. Let me put a map of New York State. So they typically have a map of our area. Where does our weather usually come from when they're saying the weather that's coming to Buffalo? Which area do they point to when they say this is what's coming? As you've all watched a weather report, does most of our weather come from this way, this way, this way? Our weather usually comes this way, whether it's coming from the southwest usually, so Ohio up to us. Usually what's happening in Cleveland is going to come up towards Buffalo. Yes, sometimes it comes from the north and over to Buffalo, but very rarely does weather come this way or this way. Our weather typically comes this way. Why? Because of this map. Because our winds are southwesterly winds in New York State. And let's just move on just a little bit. We won't have any homework other than you have the quiz, but I just want to talk a little bit. Keep your reference tables open. I want to talk about this picture. What does this mean to you? See anything on there that makes any sense? Don't worry about your packet. There's nothing in your packet. Okay, you see something that looks like math. You see numbers and you see fractions and decimals. So as soon as you guys see numbers, fractions, and decimals, you get all panicky thinking I'm going to make you do math, don't you? There's no math involved. So how about this? Why don't you open your reference table open to page 13. Search page 13 to see if now you can figure out what any of this means. All right, it's the weather at a specific recording station. So what happens is meteorologists, people who study the weather, they think like this so that they can share information about Buffalo and Arcade and San Diego really quick with a little bit of ink. They just do this. They send out this little thing. It is a station model. And either the meteorologists have all of this memorized or they use a key like this. So when they make these, the upper left-hand corner is always, read the key. What is the upper left-hand corner? Temperature. And what are the units in it? On it. They're always in Fahrenheit. So they don't have to send out, they don't have to use all the ink to say degrees Fahrenheit. They don't have to say the temperature is. They just always put 28 in the upper left-hand corner. So they don't ever have to think about it. Then we could go around. They show the circle and it says that's the approximate amount of cloud cover. So they don't say it's mostly cloudy, it's kind of cloudy, there's a little bit of clouds. They fill in this circle. What would this one be filled in as? How much percentage is that? 75. That's 75. 50 would just be half. How much the circle is filled in. Whoa, where are you looking? Because I was talking about how much cloud cover it has. Yeah, but I was looking at the amount of cloud cover one. So the circle is filled in by how much clouds there is, which kind of makes sense because when there's clouds, the sky gets filled in. They'll keep these in even fractions. In fact, they'll be so even, it's a quarter, 75, 50, and 100. So don't have to worry about, oh, is that 36% or something like that? 25, 50, 75, or 100. Jake wanted to talk about visibility. It does go similar with clouds. Visibility just means how far down the road you could see if your path was clear. Do you guys think half a mile is a lot of visibility or a little bit of visibility? I heard not a lot. Does everybody agree? You ever been on the top of a hill and been able to see Buffalo? Never? You have never seen Buffalo from a hill, Briley? Yeah, when you're driving there. And have you ever seen it off in the distance? Like when you're going up Genesee to the 219, there are times when you should be able to see Buffalo. Do you think you're only a half a mile from Buffalo? No, right where I live, there is a really perfectly lined up hill with Buffalo. I live 20 miles from Buffalo, but on a clear day, I feel like I can see in their windows in Buffalo. Can see the buildings, I can see the lights, I can see Lake Erie. I am 20 miles from Lake Erie. Half a mile is nothing. Now, yes, of course, it could get worse. You ever been in a snowstorm or fog where you really can't see the front of your car? Okay, then how much visibility would we have? I heard somebody say it. Yeah, it would be zero. Zero visibility means you can't see nothing. So what do you think it means on those days when I can see Buffalo? What do you think they put here? Not 100, well, they could put 100 miles, or they would just leave it blank. If it's blank, it means full visibility. You can see everything. So there's a difference between blank and a zero. Now this asterisk, nowhere on here does it say what the asterisk is, but I cut it off, but you guys take a look at, and you have it in front of you, right underneath where it says present weather. We could have there a comma, a period, that stick with a little stringy, a triangle, all of those. What does the asterisk mean? Snow. Take a look at all of these. How would you describe any of these words? If you had any of those on your weather report? Yeah, yes. Okay, Riley just made a face. That's all yucky weather. What do you think they put there if it's nice day? Nothing. Okay. We're going to continue on with this tomorrow. I just wanted to get started with it.